Welcome back. For our next demo, I would like to do a little bit of musics. And before getting into the music, I just would like to explain you a little bit about this final state machine. So when I was debugging the WebSocket, in the communication between the server and the client, it's usually happen like this. It doesn't work. I just need to go to the next state, keep calm and find that bug. It works. I still not understand, so just keep calm and carry on. I don't know if this final state machine is complete and consistent, but it's kind of make me the project work at the end of the day. So in today's demo, I would like to keep calm and use the force as a small tribute to John Williams. So let's open the elevator. Yay. So as you can see, there's like two ROMs containing the melody and a small piano here. And you can see in the output which notes getting pressed. And in here, as you can see with the numbers, you have 8 bits of address. So you have the address that is getting here. And for the last bit, the 9th bit is an overflow bit. So for example, when it's not enabled, it will chip select this first ROM. And when the chip select is enabled, it will enable this ROM. And then you have here the mux to decide which signal to go into the piano. So without waiting anymore, I give you Imperial March by MicroSim. That's great. I just want to fill up the addresses and then to come back to this ROM. Great. Now let's just pause. And I would like to show you the melody that is being displayed. So let's open again our very nice signal analyzer. Let's put it in here if it wants to. Yay. Let me just select the output, this value, this first ROM, the chip select, and the second ROM. And I will go with the pad. Oopsie, 2 fingers, not 3. So as you can see, I just would like to zoom in here to see what is happening. And what you can see is that this is the upper output to the piano, and we first transmit from here, and then this is getting all zeros for the rest of the melody, and this is such a transmit because this was back a 0, and now it transmits the other melody, as you can see. So let me just like this and zoom out. So one nice part about this is that you can directly navigate. So as you can see, I went to the first one, and using the control tabs, I can navigate directly to the next edges. Here just 1 unit of time, and yeah, it's very easy to navigate in the signal like this. So let's just stop this like this. Let's close this, and let's move on to our next demo. Our next demo, well, I would like to do a small Morse decoder and Morse player. So let's get to it. As I'm a bit lazy, as you might remember from last video, I would like to present you a small, instead of doing this, I would like to show you a description that does this Morse player. So this description works as follows. Let me just put back this. So you just have to provide the clock, the reset signal to reset the flip-flops, the registers to be more precise, the enable signal, and the character. So it's in like an 8-bit character, it's an ASCII code character. And depending on, for example, the letter, for example, let me show you the S. S is just going to be 111. So it's like a 16 value, and it's going to play the melody. Yeah, so essentially this is the value, and then you just have to, depending on the fact, if you have the reset, you just reset to 0, so it doesn't play anything. And yeah, just have to wait for 16 cycles, and when the 16 cycles is done, you can move the signal playing to 0. So Let me close this and let me try out this demo. So there might be some random values at the beginning. Let me check. Yeah, definitely. Let's just reset, so that's there's 0. And now let's play S, for example, SOS, for example. So S, let me put the kcalc. S is 83, I think, in ASCII. So 83 is 53 in hexadecimal. So 5 and 3. Let me just enable this again. Great, we have the S. Now for the O, I think it's 79. So 79, which is 4F. Oh, 4F, okay, it's easy. So 4F, so 4F, enable. Yeah, we have the O. And yeah, so you get it. We got the S with the O, we can stop this. So that's great. But as you can see, I can only transmit one character. And the message is composed of many characters. So let's just close this and open our new demo. So our new demo is composed of the Morse plate that we have before and the message. So the message is like a ROM which has been fine-tuned just to respond to our needs. So we have the ROM in here, which contains, for example, the hello world message in characters, in ASCII characters, and it will raise a done signal and provide, for example, just a new letter to say, okay, to the Morse player, here's the new letter, you can start playing. And yeah, it will directly just send the letter and wait for the counter to be done with the current character to provide the next letter. With that being said, how do we program the ROM? So we can just change this, but I find it a bit tedious. So I created this little script, message.py, that will, as you can see, this is the template code that we have from before, and it will just edit the ROM. So as you can see, there's like the ROM entries that goes here, and you just have to specify some bits of regex just to clean up the input values, and yeah, so it will just transcribe the ROM value into the characters. Great. So let me open the terminal, move back this. Great, let me just, wonderful, to ls, and we have our messages. So for our messages, we can, for example, do SOS. Yep. SOS from EPFL. Great. Oh, we didn't saw the message. It has been edited. So let me do again and change this. SOS from Lausanne. Yeah, as you can see, it's got edited just live. So let me just put this here so we can see the LD and the buzzer. Let me just press play and pause. So why are we going to do play and pause? It's to be able just to insert the values in the signal analyzer. Press pause. Great. Let's open the signal analyzer, put it here. Great. So what I want to do is just to put the output value, the character, for example, or any, for example, Morse in, to say, okay, I've got a new one, let's put this on the top. Great. Yeah, that should be okay. So what is happening in here, I've got an AND gate, so it's stopping the clock. So I will reset, enable the clock, and transmit. Press play. Let me reset, enable, and transmit. What is very nice about this, let me just pause this, is that we have in here our message in Morse with the pins. This is the enable, like new character, and here we say, okay, we're done. We're having our new a message that has been completely transmitted. So let me just change this in terms of value format, for example, to decimal unsigned, and yeah, we have our message. Let me do another small demo. So let me just look at the messages that I have. So let's yeah, so I would like to do this one, which has some historic meaning. It's the first message that has been transmitted using by Samuel Morse, and I feel it's a bit nice to be able to retransmit the first message in Morse using MicroSim. So let's do it. So yeah, we're done with transmitting. Let me just pause and stop the simulation. And with this, it concludes our demo about the Morse and the Darth Vader demo. Thank you very much for your attention, and see you in the next video.